Cold can be a harsh and unforgiving environment to survive and thrive in. Besides clothing, fire, and shelter, the body's main way of warding off hypothermia in the short term is to generate its own heat, primarily through shivering. In today's episode, we'll take a look at whether shivering can last indefinitely or whether it fatigues, especially as the body gets tired from prolonged exercise and lack of food. We're getting into the time machine and taking a look at a classic study by Peter Tikusis in 1999, and partnering it with a more recent study that I conducted. These two are easily the most uncomfortable studies I've personally been a part of throughout my 30-year career. The basic question is whether extreme fatigue from hard and prolonged exercise, along with inadequate nutrition, can cause shivering to become impaired. With prolonged exercise in a thermoneutral environment, we generally rely on carbohydrates, either the glycogen we have stored in the body or carbohydrates that we eat during exercise for energy. This is also the case with intense shivering, so shivering might drop as our carbohydrates run low and also possibly because our muscles are tired from prolonged exercise and can't generate as much force. So in 1999, Tikusis tested cold tolerance after 5 hours of varied and hard exercise, including 3 types of aerobic exercise, rowing, jogging, and cycling, combined with heavy weight training. Only water was allowed during this and not any food. We then were exposed for up to 4 hours in a cold and windy shower, consisting of wearing just shorts in a 10 degrees Celsius shower in a 10 degrees Celsius chamber, all with a 6 km/h wind blowing on us. Yes, this was indeed as terrible as it sounds. Of course, there was also a control condition where we were normally fed beforehand and didn't do the 5 hours of exercise. These two graphs tell the main story from this challenging study. The left one is an appropriately named survival curve, showing the number of remaining participants over the 4 hours. There was a trend towards faster dropouts and shorter tolerance times with the fatigue condition, shown with the dashed lines, but this wasn't statistically significant. The right graph shows individual responses of the 13 participants during the control trial and highlights the huge inter-individual variability in responses to the same cold stress. The thin, medium, and thick lines represent lean, moderate, and high body fatness participants, respectively. The big difference was in shivering rate, and this difference wasn't related to either aerobic fitness or body fatness. Indeed, as can be seen in this graph, some lean individuals had strong cold tolerance, while some high-fat individuals were only middle of the road in terms of cold tolerance. What predicts individual shivering drive and cold tolerance largely remains a mystery to the present day. Fun fact, I was participant number 9, with moderate body fatness and also a middle-of-the-road cold tolerance response. Another interesting finding was that there was an apparent shift towards higher reliance on fat metabolism in the fatigue trial, debunking the idea that shivering is an inflexible process that relies only on high rates of carbohydrate use. In 2016, we followed up on this question with another incredibly challenging study, where we had 8 participants sustain moderate shivering for an entire 24 hours through a combination of minimal clothing and 7.5 degrees Celsius air. They were fed normal amount of calories but using survival rations, as we were simulating an Arctic survival situation and had only half a liter of water. The dashed line shows that heat production was sustained and actually rose slightly over the 24 hours. Meanwhile, the shaded graphs show that, between 6 to 12 hours into exposure, the body seems to naturally shift to higher reliance on fat metabolism. Overall, these studies are good news for extreme survival situations, suggesting that shivering and heat production can be sustained for up to at least 5 hours with heavy exercise and no food, or 24 hours with no exercise and adequate food. This is important information for both military planners and also for search and rescue survival modeling. I hope that this look into the fascinating world of environmental physiology hasn't given you the cold shoulder. I'm Professor Stephen Cheung, and I run the Environmental Ergonomics Lab in the Department of Kinesiology at Brock University. We post new videos on different topics in environmental physiology every Wednesday. Thanks for watching. We'll see you next time.